Now let's proceed to the understanding of zeros of rational functions. And the zeros of rational functions. A zero of a rational function is a value of x that makes the entire function equal to zero. So for a rational function of a nature of r of x equal to f of x divided by g of x, where is the rational because it is in the form of a fraction, and the zeros of r of x is the value of x for which this particular fraction is equal to zero. So when you just practice an algebraic simplification or cross multiplication, we are going to analyze that g of x will multiply the 0 and the result will be 0, and f of x multiplying the 1 here and the result will be f of x. So it means that f of x is automatically equal to 0. So hence the zeros of rational function is when the numerator is equal to 0. Now let's see a simple example and a step-by-step explanation of what we've learned so far. We have to find the zeros of the function f of x equal to x plus 3 divided by x minus 3. Then the solution set is to make sure that the numerator is equal to 0. Set the numerator to be equal to 0, and it will be x plus 3 equal to 0, which means x is equal to minus 3. It means that minus 3 is the only input. When you substitute it into this particular function, it will turn this function to 0. So therefore the zeros of the function is s equal to minus 3. Now let's move to example 2 by determining the zeros of the function g of x equal to 2x minus 1 divided by 2x squared minus 9x minus 5. For this particular function, the numerator is 2x minus 1. So if I want to find the zeros as we've learned so far, we just have to equate the numerator to 0. So 2x minus 1 equal to 0, 2x equal to 1, then x is 1 on 2. It means that when the input value is 1 on 2, the whole function is equal to 0. So therefore the zeros of g of x is x equal to 1 divided by 2. We now proceed to the next example, and we are supposed to determine the zeros of the function h of x, which is equal to x minus 3 in one bracket and 5x squared plus 7x plus 2 in another bracket, all divided by x squared plus 2 all squared. And to find the zeros of this function as we've learned so far, we just have to equate the numerator, which is x minus 3 multiplying 5x squared plus 7x plus 2 to 0. Then we are going to have these two factors here. So this expression means that x minus 3 is equal to 0 and 5x squared plus 7x plus 2 is equal to 0. So we solve the first one first, and when you solve it, we are going to have x equal to 3. Then also find the factors of 5x squared plus 7x plus 2 as 5x plus 2 in one bracket and x plus 1 in another bracket, all equal to 0, which will give us x equal to negative 1 and x equal to minus 2 over 5. So therefore the zeros of the function are s equal to 3, minus 1, minus 2 on 5. So when you look at the graph of this particular function h of x, we are going to analyze that at where s is equal to 3, y is 0. And at where x is equal to minus 1, y is 0. And at where x is equal to minus 2 on 5, y is also 0. That is, the graph intersects the x-axis at where s is equal to 3, minus 1, and minus 2 on 5. This represents the zeros of h of x. Now, let's move to another example, which we are supposed to find the zeros of the function k of x equal to 2x squared minus 8 divided by 17. So the same principle, just equate the numerator to 0, then x squared minus 4 is equal to 0. So we are going to have x minus 2 and x plus 2 equal to 0. So these two factors will be x equal to 2 or x equal to minus 2. So therefore, the zeros of this function k of x are x equal to 2 and minus 2. So when you look at the graph of this particular function, you are going to also note that at where x is 2, y is 0, and at where x is minus 2, y is also 0. So here x is 2, y is 0, and here x is minus 2, y is also 0. It means the curve or this function intersects the x-axis at x equal to minus 2 and x equal to 2. This represents the zeros of k of x. So now there is a practice section for us to try our hands on them. So we have to find the zeros of the function h of x in this particular nature, find the zeros of the function f of x in this format, and determine the zeros of the function g of x equal to x plus 5 divided by x squared minus 4. Now let's proceed to the next sub understanding or next sub topic, which is on rational functions. We are supposed to learn on how to simplify rational functions. Now, simplifying rational functions. Simplifying rational functions means rewriting them in their simplest form by factorizing the numerator and denominator and then cancelling out any common factors. And it is the first and fundamental skills in working with rational functions. Just like simplifying a fraction such as 6 on 8, 2, 3 on 4, we apply the same principle to algebraic expression factors, cancelling common terms and reducing simplest form. So if I have 6 on 8, 2 goes to 6, how many times? 3. And 2 goes to 8, how many times? 4. It means 2 is the common factor between 6 and 8. So we cancel them out and we are going to left with 3 divided by 4. Now, let's work on some simple examples. So simplify the rational function 3x minus 6 all divided by x squared minus 4. First, let me look at the numerator. Is there a common factor between 3x and 6? The answer is yes. So I can factorize out 3 from this particular numeric expression here to have x minus 2 in the other bracket. Then you also look at the denominator, which will be x squared minus 4. It can also be factorized as x minus 2, x plus 2. So as such, this expression can be rewritten as 3 bracket x minus 2 divided by x minus 2, x plus 2. Which means that look at the blue color, the light blue color here. So which means that the x minus 2 are the common factors in each of the expression at the numerator and the denominator. So we are going to cancel the common terms. So the common terms cancelling out will be left with an expression of nature 3 divided by x plus 2. So this is how this particular rational function has been simplified. Now let's move to the next example, which we are supposed to simplify 5x squared minus 5 divided by x squared minus 4x minus 5. So in this particular example, look at the numerator. What is the common factor here? The common factor here is 5. So I can bring out the 5 and also factorize the quadratic expression completely, as we see here. Now, when you factorize the 5 out, we are going to get x squared minus 1, which is also difference of two squares. And we are going to also factorize the particular quadratic expression as x minus 1, x plus 1. So when you look at them, what is the common factors between these two expressions? One being the numerator and the other being the denominator. So here x plus 1 is the common factor. So we can cancel out x plus 1. Then we are going to be left with an answer which is in the form of an expression 5 multiplying x minus 1 divided by x minus 5. So our final answer will be 5x minus 5 divided by x minus 5. So this is how this particular rational function has been simplified to. Now, let's move to another example which we are supposed to simplify the rational expression 2x squared plus x minus 6 divided by 2x squared minus x minus 3. First, we are going to simplify this numerator, that is factorize the numerator completely, that is factorization. So when you are done with complete factorization of this particular numerator, we will end up with a result of x plus 2, 2x minus 3 multiplying themselves. Then the denominator 2 will give us 2x minus 3, x plus 1, which means there is a common factor between the numerator and the denominator. So here, this common factor will be cancelled out. So here, when you cancel out 2x minus 3 and 2x minus 3 here, we are going to be left with x plus 2 divided by x plus 1. So this represents the end of simplifying rational function. Now, let's move to addition and subtraction of rational function. Addition and subtraction of rational functions. Now, for these studies, addition and subtraction of rational function is a process very similar to working with fractions. But in this session, we dealt with algebraic expressions as denominators. So here, that is what you are going to see. You are going to see a fraction where we are having algebraic expression as their denominators. So we identify common denominators and simplify the expression. So that is what we do when we want to add or subtract rational function. I just have to identify common denominators and simplify the expression. So the key concept for this particular studies is number one, to add or subtract rational function, we should follow these steps. And the step one is to find the LCD, which is known as the lowest common denominator. Lowest common denominator. When you have a rational function to be summed up or to perform subtraction, what you have to put in mind is you are always going to get LCD, that is the lowest common denominator. Then the two is to rewrite each rational function with the LCD. So here, perform the addition or subtraction similar to fraction addition or subtraction. So how we do fraction addition and subtraction, we perform the same similar activity here. So here, the fourth one is to simplify the resulting expression by factoring and cancelling common factors as we've learned earlier. So now, let's see some common tricks to identify the LCD, which is the lowest common denominator. So when you see this trick, be very smart to be able to identify your denominators. The first one, LCD of real numbers. Now, if I have 5 and 3, what is the LCD? LCD is 15 because the least common denominator between 5 and 3 will be 15. What is the reason? So 5, 1, 5, 5, 2, 10, 5, 3, 15. It means that 15 is part of the element when it comes to multiplication of 5 of 5. Now, 3 is also having 15 as its element when it comes to multiplications of 3. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4 is 12, and 3 times 5 is 15. So here, if you are very smart here, you are going to analyze that the LCD can also be the multiplication of 5 and 3, which will also give us what? 15. Now let's look at 6 and 9. The common denominator that will be for 6 and 9 is 18. So it means that when it comes to the multiplications of 6, 18 is part of its element. When it comes to the set of multiplication of 9, 18 is also part of the set of multiplication of 9. So 18 becomes the lowest common denominator. Now let's go to the LCD of algebraic expressions. So when we have a plus 2 and b plus 2, these two factors are different. So if I want to find their LCD, I just have to multiply them. So the LCD of this particular two expression will be the multiplication of a plus 2 and b plus 2. Now let's go to the LCD of the expression x minus 1, s plus 3, s plus 3, 3s minus 5. We are going to analyze that s plus 3, it repeats itself in these two expressions. So s minus 1 doesn't repeat itself, as well as 3s minus 5. So here, if I want to write the LCD, I will write the s minus 1, 3s minus 5, and only take one of the x plus 3 because the s plus 3 is a common factor between the two expressions. So when you do that, you have your simplified LCD in this particular format. So the LCD for these two expressions, where s plus 3 is repeating itself, will be x minus 1, s plus 3, 3s minus 5. Now let's go to the LCD of a plus b all square and a plus b. Here, this is a repeated factor of this particular expression. So what we are going to do is, since this expression also repeat itself here in an index form, then we are going to take only one with the highest index. So the LCD between these two expressions will be a plus b all squared, because a plus b is a factor of a plus b all squared. Now let's work on some simple examples for us to understand the concept so far. So we have f of x equal to 2s minus 1 divided by s minus 2, and g of x equal to s minus 3 divided by s plus 3. We are supposed to find f of x minus g of x. Now this is the perfect solution for this question. So now f of x minus g of x will be equal to 2s minus 1 divided by s minus 2 minus s minus 3 divided by x plus 3. Now the LCD will be s minus 2, s plus 3. Now this is what we are going to do next. I'll write my LCD, then perform the normal fraction operation on addition and subtraction that we know. So here, the moment you have your LCD of this nature, x minus 2 goes here, s minus 2, leaving the s plus 3, or s minus 2 will cancel out the s minus 2, that is the factor, and is going to be left with s plus 3. This s plus 3 will multiply the numerator, which is 2s minus 1, and we are going to get 2s minus 1 multiplying x plus 3. The same way, s plus 3 will go here, s plus 3, leaving x minus 2. That means s plus 3 will cancel out the s plus 3 and left us with s minus 2. This s minus 2 will multiply the numerator of the next fraction, which is x minus 3 in this particular format. Then here, what is left of you is simple expansion, but be careful with the negative sign, because it might end you up in trouble. So here we are going to expand this particular numerator. Just leave the denominator and expand the numerator. So when you expand the numerator, which is 2x minus 1x plus 3, the expansion will give us 2x squared plus 6x minus s minus 3, because 2x times x give us 2x squared. 2x times the 3 will give us 6x. Minus 1 times x will give us minus x. Minus 1 times positive 3 will give us minus 3. Then I'll simplify this one by grouping like terms, and we are going to end up with 2x squared plus 5x minus 3. Then the next one will be x minus 3x minus 2. You expand it using the same process. Then our final answer will be x squared minus 5x plus 6. Then for this numerator, we are going to do our simple subtraction. So you seen that I didn't add the negative sign when expanding this term, and this time this is a negative expression. When you open up group like term, negative times this will be negative, negative times this will be positive, negative times this will be negative. Then you group like terms, we are going to end up with x squared plus 10x minus 9. Then our final expression for f of x minus g of x will be equal to x squared plus 10x minus 9 divided by x minus 2 x plus 3. Now, let's proceed to the next example where we are supposed to simplify this particular algebraic fraction. The LCM will be in this format. So we are first going to expand this numerator, which is difference of 2 squared, and it will give us s plus 1, s minus 1. So here, if I want to find the LCD of this particular expressions or algebraic fractions, then the LCD will be the x plus 1, x minus 1, because x minus 1 is also repeating itself here. So here, when you do that, this x plus 1, x minus 1 will go here 1. Then the 1 times will give us 2. Then x minus 1 will cancel the x minus 1, leaving x plus 3, multiplying 3 to give us x plus 1. Then we are going to have 2 plus 3x plus 3. Then our final answer will be 3x plus 5 divided by x plus 1, x minus 1. So we are also supposed to simplify the next example. Look at it carefully. It is very much expanded. So here we have x plus 1 all square, x plus 2. And we also have x minus 1 and x plus 2 as the denominators of each of these fractions. So now the LCD will be, just pause the video and try and write the LCD for yourself. So the LCD for this particular expression will be the x plus 1 all squared, because this one is a factor here, and x plus 2, because it's all repeating itself here. So here, I'll repeat the same process, write this particular LCD. It means this whole LCD goes here once. One time this will give us the same thing. Then this one will cancel one of the x minus 1. And this one will cancel out this x plus 1. Then it is going to be left with x minus 1, multiplying x minus 2. Then our results will be written in this particular format. Then expand the numerator and simplify. So when you expand the numerator, first I will expand these factors before, which will give us x squared minus x minus 2x plus 2. Then our end results will be x squared minus 3x plus 2. So I will substitute the results here. Then the results being substituted will help us to expand this expression as minus x squared plus 3x plus x minus 2 plus 3. Grouping like terms will give us 1 plus 4x minus x squared, and that will give us an expression of 1 plus 4x minus x squared, all divided by x minus 1 all squared, bracket open, x plus 2. So always leave your denominator and expand the numerator and simplify it. That will give you a perfect answer. So this time we have a practice session here for you to try your hands on them. We are given that f of x is this particular expression, g of x is also this particular expression, h of x is this expression. Find f of x minus g of x plus h of x. Continue to try your hands on this particular type of question to get more understanding on rational functions.